the extra credit, I'll be doing enthalpy of solutions, which deals with why solutions form. Energetically, it shows how solutions form. So first, I want to talk about the term like dissolves. Like, and that term deals with the polarity of substances, and specifically the polarity of a solute and a solvent and how they would form into a solution. The basic equation for the enthalpy of a solution is as followed, which is delta H1 plus delta H2 plus delta H3 equals the delta H of solution. The first delta H, which is delta H1, that deals with the breaking down of the solute, and basically you have to determine the intermolecular forces of it, and based on the strength of the intermolecular forces of the solute, that's how much energy it's going to take to break it down, and this will always be a positive value. So this marker's not working with me. And this will be an endothermic reaction. So endo. The second H, delta H, deals with the breaking down of the solvent, which is going to be dissolving the solute, which leads to the making of a solution. So, and delta H of 2 will also be a endothermic, which will make it a positive delta H. So we have delta H of 1, which is breaking out of the solvent, and delta H2, which is breaking down of the solvent. So now we have delta H3. And delta H3 is delta H3 is the intermolecular forces that will form between the solvent and the solute, making it into a solution. And that will most of the time be an exothermic solution, since the intermolecular forces are favorable depending on if they're both polar substances or non-polar substances. So and this will be a negative delta H. Now, the delta H and if you combine all three of these, you'll eventually get the delta H of the solution. Now, if your reaction is exothermic, that means the solution is favorable because it is releasing energy and does not require to take in energy. However, if your delta H of solvent is endothermic, it means that the solution is not favorable, since you will need to find the excess energy. You need to find excess energy to bring in. So to write that down, we'll put a delta H of solution if it is exothermic. A solution will form. And if it's endothermic, that means the solution is not favorable. The reaction is not favorable. It means it's not favorable. And a classic example of this is oil and water mixing. If you try to mix oil and water, it will probably not mix, but we can prove that with this equation. So what we'll do is we'll have the delta H with the example of oil and water. oil and water. So if we use the example of oil and water, first we'll have to break down the oil and see what intermolecular forces the oil has. So oil is usually a non-polar, oil is usually non-polar, and it usually doesn't have a lot of OH groups. Like it's not like water, which is polar because it has oxygen and hydrogen, which forms an OH group. But oil is usually non-polar because it has a lot of carbons and hydrogens, which makes it non-polar. So if you look at the intermolecular forces of it, it only has dispersion forces. And dispersion forces are not the strongest intermolecular forces you can have, so it'll be a small positive delta H. And this is going to be your delta H of 1. Your delta H of 2 will be the solvent, which is your water, or H2O. Water goes to the third tier of intermolecular forces, which has hydrogen bonding. And that is a very strong bond to get rid of. With hydrogen bonding, we're going to put, it takes a large amount of energy, so it'll be a large delta H. And then you will have your the delta H of 3, which is the mixing of the two. This is going to be a small exothermic force because these two aren't favorable when it comes to combining, because you'll have to combine. It'll be a small negative force because it'll release a little energy, since the intermolecular forces don't take energy to form usually. So it'll be a small negative delta H. So if you add all these three together, which we don't technically have the exact values on me right now because you'd have a table with that, but if you combine all these together, the delta H of solution will be a large positive delta H, which makes it endothermic. If it's endothermic, we saw earlier that when something is endothermic, it is not favorable. So this is why oil and water do not mix well together, because if you look also just at oil itself, usually oil is nonpolar, and water is a polar solvent. So that's why these two won't mix. And this is how you would use this equation to express the dissolving of substances, and using their enthalpy to express if they would dissolve together or not.